Hello and welcome back. In this video, we'll look at convolution 2D transpose. And for this, as before, what we'll do is we'll first create the input and the filters. So for the input, so let's create the input. And for input, we need the shape. And the shape is right here that we'll use. And this is for 2D. So we have conv 2D, and that's the shape we'll use here. At the same time, we need the shape for the filter. So let's try and put that right there. So the shape for filter is height, width, output channels, and in channels. So let's write that here. Now for the input, we'll create the input x. X is equal to tf dot constant, and because this is going to be two-dimensional, we'll create a two-dimensional array of ones. Let's say 1 by 1 by 1 and another 1 by 1 by 1. And the reason I'm using value of 1 is to keep the calculation simple when we do it manually. And if we try to print the shape of this x dot shape, the shape is going to be 3 by 3, and that's what we are looking for, the height of 3 and width of 3. Now we need to add the dimensions for the batch. So for batch, let's add a square bracket on the outside. That will add a dimension here for 1, and then for in channels, what we'll have to do is add a dimension the right side of this. That is, we would have to add square brackets around the ones that we have, and so I'm going to copy that, paste that right here and here, and this should give us the a shape that we are looking for. Only have an extra square bracket there. So now we should get, so we have 1 by 3 by 3 by 1. So this 1 stands for the batch, this 3 by 3 stands for the height and width. And then finally we have the in channels, which is 1. Next we need to create the filter. So let's create a filter. F is equal to tf dot constant, and this filter will create a 2 by 2 filter with values 1 2 comma uh, 2 1. And if we look at the shape of this, print f dot shape, we now have a shape of 2 by 2, and that's the height and width. We now need to add the dimensions for the output channels and the in channels on the right side right here. And for that, we'll add square brackets. So I'm going to add 2 square brackets around each of these values, and that should add the dimensions to the right side. So we now have the dimensions 2 by 2 by 1 by 1. And before going any further, what we'll do is we'll try and perform this calculation manually, and then compare our results with what we get from the code. So we'll first create this particular input, and I'm going to draw squares. So we have 1 1 1, and so we have 3 by 3, so we need a total of 9 squares. And thinking of these as pixels, values in pixels, so we have 3. And then next we need to draw the filter. So let's say the filter that we have is this. I'm going to put the values of 1 2 2 and 1 inside of this. Now what we are going to do is, for each of these squares that we have right here with a value of 1, we are going to multiply each of these values and then put that right here. So this is going to be another square, and with let's say 4 squares, 1 2 2 and 1, because 1 multiplied by 1 is 1, that is here. And then we have 1 multiplied by 2 is 2. So if I can draw lines, let me try and do that. So we are going to multiply this one by this one and then put that right here. and we are going to multiply this one by these two and then put that right here. Then we are going to multiply the same one with this two and put that right here, and then we are going to multiply this one with this one and then finally put that right here. So essentially we are going to multiply each value of that we have in the input matrix with each input tensor to each value in the filter and put that down there. So let me delete these lines now because you know how we got them. Next, what we'll do is similarly uh, we'll have to multiply the values from other values from the input tensor. The next thing to do is we multiply this one with all the values in here and then put that right here. So let's say this is a next set of four squares we have 1, 2, 2 and 1 and so on. Then we have the third one. So let's draw that here. So we have 1, 2, 2 and 1. Uh, so that's what we have for the first row. Then we would do the same thing for the second row where we have, let's say, this set of squares 1, 2, 2 and 1. Then again for this middle one we would have a square, four squares, set of four squares 1, 2, 2 and 1, and then we go to this particular value in the input and we multiply that with the filter, we get the value 1, 2, 2 and 1. Next we are down in the third row, and in the third row again we multiply the value of 1 with those in the filter, we get a value of 1, 2, 2, 1, and then again we multiply this value with the filter to get a value of 1, 2, 2 and 1, and finally we have this one last value in the tensor. We multiply it with the filter to get value 1, 2, 2 and 1. So this is an intermediate step. After we are done with this step, next thing to do is we need to combine the values. So here's what we are going to do. I'm going to write the output here. So this pixel stays as is. So we just draw the square for that. That's the one that stays as is. Now these two from adjacent set of four squares will combine them. So that is a 1. Then 2 plus 1 is 3. So we put a 3 there. Then we also would combine these two values. And so we have a 3 right there. And this 2 stays as is. So we just put a 2 there. Next, we are going to combine. Let me use a different color. So next we are going to combine these values. So this is going to be 2 plus 1, 3. So let's put a 3 there. Then we are going to combine four values. So 2 from the top and 2 from the bottom. So these values 1. So we have 2 plus 2, 4, plus 1, 5, plus 1, 6. So we put a 6 there. Then we keep going and we now have these set of four values. As you can see, 2 plus 2, 4, then plus 2, 6. So we put a 6 again here. Then we have these two values, which is 1 plus 2, that is 3. So we put a 3 there. And likewise, in the row below that, we would perform a similar addition. We have these values. This is going to be 2 plus 1, 3. So we put a 3. Then we have this set of four values that we need to add, which is 2 plus 2, 4, plus 2, 6. So we have 6. Then we have another set of four values, which are these values 2 plus 2 plus 2, 4, plus 2, 6. And so we put that right here. And finally, in that, we have these two values 1 plus 2 is 3. So we put that right there. And going back to the last set, here the 2 stays as is, so we put a 2 like so, and then we would add these two values. 1 plus 2 is 3, so let's put that there. Then we have 1 plus 2 again, that is 3. So we put that there. And this one stays as is. So we leave the one there as is. And that is the final output we get after performing the transpose. And as you can see, that was our filter. This was our filter. Then this was our input. This was an intermediate step, and then that's our final output. This is our final output. And as you can see, the shape has changed from input. So input we had 3 by 3, now the output is 4 by 4. So let's see how we can perform the same calculation using the TensorFlow. And for that, we'll create a new variable. The variable is, let's call this result, is equal to tf.nn.convolution2d underscore transpose. And here we have input is equal to x. Then we have the filters is equal to f. Then we have the output underscore shape is equal to 1 by 4 by 4 by 1, and that matches what we have up there. And after that, we have the strides is equal to, let's say, 1 by 1 by 1. Then we, after that, we have the padding, let's keep it as valid. Then we have the data underscore format. Data format is the same as we have been using, which is n for batch, height, width, and channels. Then we can print the shape of result.shape, and finally we can look at our output result, and let's convert it to a numpy array. So let's run that, and there is an error. So strides received, so it is expecting either 1, 2, or 4, and I've put 3 values here. So let me change that and put just one value, and this gives us the output. And as you can see, it's the same as what we had. So we had the values of 1, 3, 3, 2, and those are right here. Then we had the value of 3, 6, 6, 3. So these are the values in this row. Then we have 3, 6, 6, 3 again. So that's that. And finally, there we have the values 2, 3, 3, 1, and that's this row. So this is how we can perform convolution 2D transpose in TensorFlow. If you have any questions or comments, please do let me know in the comment section below. I hope in this video you got an intuition about how to perform convolution 2D transpose, and the next video will look at 3D transpose. Until then, thank you.